Hello guys, this is the tutorial number 1 on Introduction to PSPICE. In this tutorial, I am going to explain what is PSPICE, how to download and install the free version of PSPICE software in your PC or laptop. Finally, I will explain how to simulate the circuit using this PSPICE software with an example of a simple RLC series resonance circuit. Let us see what is PSPICE. PSPICE is an acronym for PC version SPICE, and SPICE is an acronym for Simulation Program with Integrated Circuit emphasis. We can simulate analog as well as digital circuits using this PSPICE software. Actually, PSPICE simulation software is not an open source software, but a student version is available freely. Hence, I am using student version 9.1 PSPICE simulation software for explaining the simulation of circuits. Next, see how to download and install the PSPICE software. First, go to Google search page, type PSPICE links in search box, select PSPICE links in the search result. After clicking on PSPICE links in the search result, a new page will open. There you have to click download locally hyperlink. This hyperlink downloads the PSPICE student version 9.1 as a zip folder. You need to extract the files from this zip folder by choosing your own folder and directory. After extraction, you will get a message like 18 files are extracted successfully. Then go to your chosen folder and click on setup file. Actually, it is an executable file. Just after clicking the setup file, it starts installing the software in your system, and it takes hardly 2 to 3 minutes. Finally, it will ask you to choose the interface mode. You have to choose schematics interface mode, not capture interface mode, because student version supports only schematic interface mode. Now we will see how to simulate the circuits using this software. I have taken a simple RLC series circuit with a resistor of 200 ohms, inductor of 1 millihenry and capacitor of 1 microfarad with variable frequency AC supply with magnitude 10 volts. From the given data, the resonant frequency is found to be 5.035 kHz and maximum current through the circuit at resonance is 50 milliamperes. Let's see the result in PSPICE simulation software. Means we will simulate this RLC series circuit in PSPICE software. Go to Start, select Schematics, click on Schematics icon. It will open a schematic editor window. First, you need to identify the elements or components required to build the circuit. Okay, this is the place where we can build our circuit. So in RLC series circuit we need a resistor. So in the search box type R and press enter. So you will get a resistor symbol. Then you can place that resistor on your circuit editor window or schematic editor window. So similarly you need one inductor, type L, press enter, you will get inductor, press type C and press enter, you will get a capacitor. So then you need a sinusoidal signal generator. For that I will take a V sign. So next we need a ground point. Next we need to do the wiring connection from one element to another element. So now this is an icon which is used to draw the or use it to connect one element to another element. This is a wire connection. Click from this point to this point. Next to this point to this point. Similarly, complete the circuit connection. Now your circuit is ready. Now you need to set the attributes of you have to change the attributes of these elements. So because in our example we have taken resistor of 200 ohms, inductor 1 millihenry, capacitor of 1 microfarad, but by default the resistor value is 1k, inductor 10 microhenry, and the capacitor is 1 nanofarad. For changing the attributes or values of these elements, we need to double click on the element. Okay, so in this case we need to change the 1 kilo ohm to 200 ohms. So the remaining attribute bits need not to worry. Okay, so save changes to current attribute S. Now change the value of inductor from 10 microhenry to 1 millihenry. Save attribute. Click OK. Capacitor from 1 nanofarad to 1 microfarad. U represents. Use the symbol for micro. Save attribute. OK. So then change the property of the properties in properties of voltage signal generator. So the DC is 0. Save attribute. AC 10 volts of magnitude. So then offset voltage considered as 0. Amplitude of the sinusoidal signal is 10 volts. Save attribute. Frequency approximately I will write it as 10 kilohertz. Save attribute. OK. So next step, you need to save the circuit. Go to file menu and click on save as. Then use a you can give a name to this file. So I have taken test circuit 1. Save it. Next step, you have to set up the analysis. So there are different types of analysis: DC analysis, AC analysis, transient analysis. But for this resonant circuit, we need to do AC analysis. Hence, we need to set up the AC analysis for the circuit. Go to analysis menu, click on setup. Okay, then use AC sweep. AC sweep gives AC analysis. DC sweep gives DC analysis. Similarly, there are so many analysis options available. We can choose the corresponding analysis with respect to the given circuit. For AC sweep, the AC sweep type I'll change linear to decade, and start frequency is 10 Hz. Keep it as it is. End frequency change from 1 kilohertz to 1000 kilohertz. Okay, then points per decade and 101 I'll change to 1000. If the number of points per decade increases, accuracy increases. Click OK, close. Now you need to simulate the circuit. Go to analysis, click on simulate. Simulation results you will get in another window. To get the frequency response, go to trace, add the trace. So I of R1, where is the current through the resistor R1. Okay, so this is the frequency response of the given RLC series circuit. Okay, now we need to cross verify what is the values we found in found theoretically, and what is the value we are getting after simulating the circuit by using this PSPICE software. Now we will see what is the maximum amplitude and at what frequency we are getting a maximum amplitude. So for this, go to toggle cursor. Okay, so which gives what is the value at the cursor position. You need to move the cursor position from unknown position into so the required position or a peak level. So this is a cursor peak level which gives so the A1 gives the maximum values, A2 is the minimum values. A1 first value is the x-axis value and the second number is the y-axis value. The x-axis value is 5.035k. So this cursor position, this is the cursor position. Okay, so which gives the frequency, that is the resonant frequency, that is equal to 5.035 kilohertz. So then the y-axis, this is the cursor, this is the maximum value, that is equal to 50 milliamperes. Okay, now we will cross verify with the theoretical value. How much we got? Resonant frequency is 5.035 kilohertz and Imax is 50 milliamperes. What is the answer you got here? The same, 5.035 kilohertz at 50 milliamperes. So then successfully we have simulated RLC series resonant circuit. Thank you.